In this video, I'm going to demonstrate three different changes that we're going to make to this lens. We're going to increase the overall diameter of the lens, increase the size of the treatment zone, and then also decrease the sagittal height or depth of the lens out in the periphery. So the first thing we'll do is make this lens a little bit bigger. I think for this cornea, we can go up to an 11.5. And then when we do that, we can go back here, we can see that the red, the OZ, and the blue, the IC control points have also shifted outward. They started out at 5.6 millimeters and 6.2 millimeters, so they've both shifted out about 0.3 millimeters. With this patient, I'm going to probably try to go out a little bit farther. Maybe we'll go to a 6.1 and then a 6.7. So I'm just going to drag outward 6.1 and then drag outward to 6.7. A larger treatment zone will generally give better quality vision, and then it will also give us a little bit of leeway in case the lens decenters a little bit. In this particular case, the lens for the right eye didn't decenter very much, but the lens for the left eye was decentering. The cornea does have a little bit of asymmetric tilt to it, and the lens was just following the natural anatomical contour of the cornea out and down to the side. So with a slightly larger treatment zone, even if the lens does decenter a little bit, we can still maintain better optics. Now after moving these positions, we'll notice that our power has dropped about a diopter, and so we need to compensate for that. The base curve is now a diopter steeper than when we started, and so we will just click up at the red control point until we're back to approximately the 1.6 where we started. Anytime you change the base curve in an ortho-K lens, even if you're in 100% mode, it is a good idea to click through the different meridians to make sure that everything is pretty uniform. This looks pretty good. I think there might be just this one oblique meridian here where I would give it one more click. So since we only want to adjust this meridian here, we'll go into 25% mode, click up one time, and that should make everything very uniform all the way around now. So this one was fairly easy to touch up. Sometimes you'll get quarter, half, sometimes even a slightly more than a half diopter variation between the meridians, and just need to go into 25% mode and fine tune each one so that it is uniform. And then the final change we're going to make is to decrease sagittal depth out here. And the idea behind doing this is to lift the edge of the lens, which will allow the center of the lens to settle down onto the apex a little bit more. This patient is undercorrected currently, but the base curve is probably flat enough for this refractive error. And so if you have a lens that is vaulting the apex by too much, if the edge of the lens is digging down and causing the rest of the lens to be propped up above the surface of the cornea by too great a margin, then we can get reduced treatment. So here at the edge, we're currently at 2051 microns. I'm going to decrease this by, let's go 17 microns. So our new target is going to be 2034. And you can see the graphic as we make these adjustments. Center of the lens starts to settle down closer to the cornea. Of course, this is just a representation. It is a calculation, and sometimes it's not an exact representation of what's truly going to happen in life, but the principle still stands. Going a little bit over. Okay, and now we're at 2034, about 17 microns more shallow than when we started. So those are the three changes. This lens should be ready to go.